watching at home. Okay, so yesterday we had a couple of questions for you guys about which of these triangle theorems or whatever are viable. So, what I mean by that is this. We had a bunch of different ones to check out. We found out that side was enough to prove that two triangles are congruent, meaning that if we have two triangles like this, and that all of the sides have matching pairs between them, then that these two triangles will be congruent. Turns out the angles will also be congruent automatically if the sides are. Remember, for a triangle to be congruent, all the angles and the sides have to be the same. We found out yesterday that angle, on the other hand, if we have two triangles. Thank you. If we have sets of angles like this, that does not necessarily mean they're congruent. So this is a no, right? It doesn't mean they're not congruent. We can't say that, right? Because they could be, right? But it isn't enough to say for sure that they will be congruent. Imagine, the way I remember this one that it doesn't work is I think of like an equilateral triangle. Equilateral triangles have equal angles and equal sides. So if I have an equilateral triangle, what are the measure of the angles? Equilateral triangles have equal angles and equal sides. 60, right? 60, 60, 60 makes 180, right? So imagine two equilateral triangles. Well, if they're equilateral, they both have 60, 60, 60 for their angles, right? So their angles do match. However, think of an equilateral triangle that's this big. Now think of an equilateral triangle that's bigger, right? They have the same angles because they're both 60, 60, 60. They're equilateral, right? But maybe one's a 1, 1, 1 triangle and another one's like 5, 5, 5. So they will not necessarily be congruent. So that's not enough to prove it. So angle doesn't work. We could have two equilateral triangles of different sizes, right? Yesterday I wanted you guys to check out this one. And we did that in class, SAS. That's where we have two triangles, where they have two sides that are congruent. And one angle in between those sides that's congruent. And it turns out those will be enough to prove that they're congruent. So the triangles themselves will be congruent with that information. What happens is we get those two sides in that angle, and it kind of locks the triangle into place where that last segment kind of has to be that size and going at that angle. So again, imagine we have this right here. I've locked in an angle and I've locked in my sides by drawing that, right? How many triangles can you make out of that? One, right? You have to connect it like that. So if you know another triangle has the exact same angle and sides, which it's close enough, okay? Then it has to be the same, right? It locks it in. So side angle side does work. Today you were supposed to check out angle side side. We're praying that this one works, right? And then also angle side. Oops. And then one more. What was the last one you needed to check?
Side angle.
Very good. Angle side angle.
Yeah.
Okay. So these three are the ones I had you check for homework. I'm sure you all checked them. Here's what you would have done, right? Let's check ASA and go from the top. So ASA means we have two angles that are locked in and one side that's locked in for our triangle. So let's take a look at that. Here's ASA. Cool. All right. So that means we have two sides that are going to match perfectly. So let's make this length 4. And let's make this one length 4. I'm choosing 4 randomly. Again, it could have been 5 and 5, 6 and 6, root 2 and root 2. Doesn't matter as long as these sides match, right? And then on either side of the side, we're going to have two angles that match. So, David, my boy, give me an angle that's acute and a multiple of 10. 60? Nice. All right, so I'm going to draw a 60-degree angle here. Now, the length of this side is not locked in. Doesn't matter how long the side is. I'll cut it off later. We'll experiment with that. That's 60. All that's important is that the angle is the same on both of these triangles. So we have 60 degrees here. So these are both 60. All right, Landry, give me another angle that I'm going to put here that's also acute and a multiple of 10. any of them. Wow, good job. Okay, so here's 50. So again, I'm going this direction, so I'm going to look for the 50 here. That's a 50-degree angle. And notice that once I've set my angle, once I've chosen that angle, and again, I'm choosing angle, side, angle. Once I've chosen my two angles and my side in between, it kind of locks my triangle in place, doesn't it? They intersect and they make a triangle. So just by choosing the two angles and a side in between, a triangle appears. Same thing here. If I do 50 degrees, the triangle shows up. And both triangles are exactly the same. So angle, side, angle, knowing that about a single triangle is enough to prove that both are congruent. So if we know, and again, how we read this is like this. There's our angle, there's our side, there's our angle. So if we have matching angles, matching side, matching angle in that order, then we know that the triangles, all of them will be congruent. So we know that these angles are going to be the same, we know these sides are going to match up, right? Everything is free. Cool? So angle, side, angle does work. For angle, side, angle, I'm going to run out of room here, all right? For angle, side, angle, that's where we have matching sides and then matching angles on either side. Cool? All right. Let's try angle, angle, side. This one's a little bit harder to illustrate. Now I'm going to read this backwards because these are the same forward and backwards. Doesn't matter if I read angle, side, angle, or angle, side, angle this way. It's the same thing. Same thing for this. Angle, angle, side is the same thing as side, angle, angle. So I'm going to make a side first because it's easier to start out with that. Let's make a side length of, I don't know, how about 5? Doesn't matter. And now I'm going to make 2 angles. Now notice these angles aren't surrounding the side. So it's not going to be on the left side and the right side like this one was. See how they're on the left and the right side of the side? They're going to be on one side of it. All on one side. So I'm going to put an angle here. See what I think. Alex, give me an angle that's acute and a multiple of 10 degrees. Huh? Say again? Okay. Give me an acute angle that's a multiple of 10. 20. All right. So I'm going to put a 20-degree angle here. Does everybody see how I'm making that 20-degree angle? I'm putting my protractor in the end of this line segment. And then I'm finding 20, putting a dot, and then I draw my line however long I want. Remember, this side is not going to be locked in. Right? The only thing that's permanent is that side right there. So there's a 20-degree angle. I'm not going to mark that. I'm just going to put a little curve. Same thing here. There's a 20-degree angle. All right, so these are both 20-degree angles. Awesome. Now I'm going to make another angle. And it's going to be after this angle, right? It's going to be side, angle, angle. So side, here's our angle, and we're going to make an angle over here. Jess, give me an angle that's multiple of 10 and acute. 40, awesome. So I'm going to put my protractor here. 40 degrees is right there. Is everybody with me on that? See the 40? Right? Now, when I do that, notice that if I drew the line from here to here, it would cut this shorter, which isn't allowed. I have to have a side of 5, right? So when I do this, I want to make sure that I actually do make a triangle. So here's 40. I want to make sure that wherever I do it, it does end up hitting about right there. And that looks like it will. So there's where I put my dot. There we are. So there's my 40-degree angle. And notice that does kind of lock the triangle in place, right? There's only one triangle I can make with that. Same thing here, if I go to make a 40-degree angle and make sure it actually does connect with that to make a triangle. Looks like I'm here. And we have the same triangle. So angle, angle, side does work. Here's our angle, and here's our side. Are you seeing how that works? I didn't go this direction and say angle, side, angle, because I would have been skipping an angle and a side here. Does that make sense? Right? I have 2 consecutive angles, one after the other, no angle skipping, right? And then a side right after it. Are you cool with that? All right. So angle, angle, side does work. I'm going to put this here, and then we're going to circle this one. This worked before. Angle, angle, side is when you know that you have two angles, two sets of angles that are congruent, and one side. So we have angle, angle, side. Let's check out ass, right? Some of you guys go to the mall, and that's what you say. All right. Shame on you. You guys are praying that this one works. Praying so you can write this on a test and I won't mark it wrong.
I'll just write it.
All right, so what we're going to do is we're going to make two sides that are congruent between the triangles and then an angle that is not between the sides congruent. So I'm going to draw the sides first. I'm going to read it backwards, SSA. I think it's easier to draw sides than it is to draw angles. So somebody give me a side length, preferably a whole positive number.
12.
12. That's really big. All right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's 12 across. All right.
Could have been a small.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I believe those are both 12. Okay, cool. So we have two congruent sides. Awesome. And now we need two more congruent sides, right? A pair of sides and a pair of sides is what we need. So now, because I don't want to set a specific angle, right? The angle in between those sides doesn't matter. I'm going to need to go off at some angle here that isn't 90. I don't want those angles matching. Otherwise, we'll have side, side, angle, and side. We already showed that that's okay. So I can't count squares for this one. I'm going to use my ruler for this to show that they're the same. So somebody give me a measurement between 0 and 6 inches.
3.
3 inches, a very popular choice. So here's 3 inches, right?
So about 12.
And then I'm going to do a different angle, okay? Different random angle, non-specified.
That means it'll be different, right?
I can come up there and be your ruler.
All right.
Wait, so now they have to be different, right?
You can already tell it's going to be different, right?
Yeah.
Right? The angle in between doesn't have to be the same, right? Because it says just, hey, we have two sides next to each other, no specified angle. Then we have another angle. So give me an angle measurement that's acute.
40.
40, all right. So I'm going to go from here and draw a 40-degree angle. Now notice when I do this, it's going to cut this red guy, right? So that's not going to work. So maybe I can do a 40-degree angle here. Nope, that's not going to work either. So I'm kind of locked into a specific angle that I had to have, right, in order to even make this a triangle, which isn't going to work, right? So I need an angle that's congruent for both of them. I don't know if I can even do that, right? That might not even be given. So this one does not work. Turns out ass and ass backwards, SSA, are both wrong. Which turns out, it makes sense, right, that ass backwards would be. Yeah, I know, right? So that's not going to be enough. There is one case where ass works. Okay? And here's the case. It's when that angle is 90 degrees. So if I have a triangle like this, that's a side length of 5 and a 90-degree angle. If I make another side length of 5, and I make sure that the hypotenuse matches as well, so that's a, what is that? Looks like 1, 2, 3, let's measure. Looks like a hypotenuse of 2 1/4. 2 1/8, 2 1/4. Here's 2 1/4. And I make sure it's 90 degrees. It'll end up being the same triangle. So I made sure these matched, right? And that they're 90. And I end up with the same triangle. So angle, side, side does work with 90 degrees, but only 90. Which is why we have a special name for it. We don't call it ass, not just because teachers don't let us say it, but because this reminds you that it has to be a 90-degree triangle where it works. This is hypotenuse leg. This is the hypotenuse, and that's the leg. And we already know that that's going to be 90 because only 90-degree triangles have a hypotenuse, right? That's the idea. And the hypotenuse is always the side across from the 90. Why is the hypotenuse always the side across from the 90? Better question, why is the biggest side always across from the 90 in a triangle, in a right triangle?
Angles. It has to be.
Why?
Because that's the only line that's slanted. slanted lines are longer.
Slanted lines are longer, that's true. That's true. Anybody have another way of explaining it? Why is the biggest side on a right triangle always across from the 90? Yeah.
Because that side is the, if you were to do the diagram theorem to the other two sides, it's always going to be bigger than one of those.
Right. We have a squared plus b squared equals c squared. So we have two square numbers adding up. They're going to make a bigger number than themselves, right? So if you have a number 5 and you add anything to it, will that be bigger than 5? Yeah. If you have a number like 6 and you add something to it, will that end up being bigger than 6? Yeah, it will. So this will always end up being the bigger side. Another way to think of it is that because this is 90, the internal angles of a triangle always add up to what? 180, right? So that's 90. What's the biggest this angle could be? What's the biggest this other angle could be? 89.999999999, right? Because there has to be a little bit left over for this guy, right? Otherwise it's not a triangle. Triangles have 3 angles. So this will always be the biggest angle. Guaranteed. Has to be, right? And if it's the biggest angle, it opens up the most. And the bigger we open up, the bigger the triangle will be. If I open up my hands like this, right? It's a very acute angle. The other side right here is going to be very small. But if I open up to a bigger angle, notice that other side gets a lot bigger. So the biggest angle opens up to the biggest side. This is always true. The smallest angle will always open up to the smallest side. That can be really useful. So it turns out ASS doesn't work unless we're talking about right triangles, and then we call it HL to remind us that it only works for right triangles. Hypotenuse leg. Not 2 legs, but hypotenuse leg. Cool? Rad. So, I got something for you. Let me go grab it. Actually, let me start printing it, because I think I printed it earlier and it didn't come out. Where it came out like really small, you know how you print it out, it's like this big when people take the whole page. Annoying as the word.
I want to think of the seconds.
So while that's printing for you, I'll have your full attention here. So, for each pair of triangles, I should say of there, state the postulate or theorem that can be used to conclude that the triangles are congruent. So, for now, we're keeping it relatively simple. It's not simple because it's new, right? New is weird and weird is difficult, right? But it's not as hard as it could be because eventually we're going to be proving these theorems, right? All theorems can be proven. But in order to do that, we have to make one of these that we listed a postulate. So, we've got side, side, side that works, right? If we know all 3 sides, then the triangles will be the same. We've got angle, side, angle. We've got side, angle, side. We've also got angle, angle, side. Those all work. Last one is HL, which is really ASS theorem just for 90-degree triangles, right? So, these are our possible ones. In order for these to be theorems, one of these has to be a postulate. Now remember, a postulate is something that we accept to be true because, of course, it has to be. So we're going to make this one right here, for this class, our postulate. It's the thing we assume to be true because how could it be anything else? When we draw a triangle with a certain angle and another certain angle, right, with a side that matches in between, we end up getting the same triangle. We can't prove that, but it just happens, right? We can see that happening right here. So we're going to assume it to be true, and then from that, we're going to prove the rest. We're not going to do that today. We're going to do that next week. For now, we're just going to practice using these theorems. So for number 1, we want to prove these triangles congruent. Now be careful. There are multiple triangles in number 1. We have the left side triangle, the right side triangle, and then the big triangle. Now, I bet you can tell that the big triangle is not going to be congruent to the smaller triangles, right? I mean, the way I said it kind of gives it away. One's bigger than the other, right? So we're trying to prove the left side and right side congruent to each other. Triangle FIG to triangle HIG. Fig to Hig. And if you notice, they've already given us some stuff. They said that this side is going to be congruent to this side, and that this angle is going to be congruent to this angle. That's cool. So we already have SA. Another one of these. So we could prove SAS. We could do SAA. We could find another angle and do ASS, right? We need one more bit of information to be able to prove that these triangles are congruent. Does anybody see it? What other side or angle do those two triangles have congruent? Huh?
Are the two bottom ones the same?
The two bottom ones. The two bottom angles? What do you mean?
Are they the same?
Are the bottom sides?
Yeah.
Can't prove that necessarily. Turns out they will be. But unless you can prove that by talking to me right now, can't assume it.
Alright.
Turns out because these angles are both the same, this bisects that angle, which means it bisects the side. Right? We talked about the bigger the angle, the bigger the side. So if the angle's the same for both, the sides will be the same. Works in that case, okay? But we can't assume that. We don't know that right now. There's another way, a much easier way. What else do you know that's congruent about these two triangles? Seeing it is the battle, guys. It's the entire battle. So we're going to spend some time on this. We're going to sit and wait until we can see it. Yeah?
They both have a 90-degree angle.
How do you know that?
You don't. It's the same line.
You don't necessarily. Turns out they will. And I can prove that later. But you don't know that yet. There's an easier way.
I don't know.
For reference, here are theorems that we can use. Let me zoom out a little bit. There are theorems that we can use. Nancy?
I will use the side, angle side,
Okay, so we have side, we have an angle. Where's the other side that you see that's congruent?
GI.
GI. Notice that GI is shared by both, so it has to be congruent. They share it. They use the same side. GI is congruent to GI. That's the reflexive property. Anything equals itself, right? So it turns out we have side, angle, side here. Two matching green sides, two matching angles, and two matching sides guaranteed. Now that we know the triangles are congruent, okay, everybody have this in their mind right now? Because I'm going to mess with this diagram. You got it? Okay, that was enough to prove it. Now that we know that the triangles are congruent, we know that this side is congruent to this side, right? We do know that. Cool. So we also know that these angles right here will be the same, and that these angles right here, let's use a different color. Let's use like these angles right here will be the same. Because the triangle's congruent, all of its parts will be congruent, right? They correspond. Is there enough information here to say those are 90, the blue angles?
Yes.
How do you know?
Wait, I don't know.
Well, it says that the triangles are congruent, but how do we know that they're 90?
Oh.
You know what I mean? You're not saying these are 90. Right?
Never mind.
Is there enough?
No. I don't think so, because you don't know the exact length of the. I'm not good with words.
It's okay, it's okay. This is tough. Is there enough or is there not? We're going to find out in the next few days. Probably next week. But we do know the triangles are congruent. Doesn't matter whether they're 90 or not, whatever they are, they're the same. Cool with that? Let's look at number 2.
But they're not the same triangle, right? You said one was
They are the same triangle. Both are the same. This guy right here. No. Look. Stay with me. This triangle right here is not congruent to this triangle.
Right.
You need to know the angle measurements to know if.
I'll get there in a second, Noah. So,
Yeah.
this left triangle is congruent to that triangle. They are the same in every way. They have both matching angles here, here, and here, and they have matching sides here, here, and here. Okay? But this big triangle is not congruent to the other two. I think that's pretty easy to say.
Yeah.
Right? So, looking at number 2, we have two triangles, a top and a bottom triangle, right? Are they congruent? And if so, how do you know?
No.
So far, they've given us that we have one matching side here and here. And we also have another set of matching sides here and here.
Side.
How do you know side, side, side? Luke,
That's-
what's the missing side that we haven't written down on our diagram?
The one in the middle, which has to be congruent,
And P, how do you know it's congruent?
because they share it.
They share it, right? Shared sides. So by side, 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 these two triangles are congruent. Number 3. Things get harder now.
Angle, side angle.
Angle, side, angle. Before I get to that, we have an angle here and an angle here that match. And we have a side here and a side here that match. So where's that other angle that you're seeing, Noah?
Like right at C on both sides, right?
Mm-hmm. These angles right here are congruent. How do we know that? Vertical angles theorem. Exactly. Remember that from first semester? Sister theorem? Your words, not mine. Vertical angles will be congruent always. So we have angle, side, angle. How do you feel? Why don't you try these on your own?
So are they all going to be
I'm
congruent?
going to go get you your worksheet. They will not all necessarily be congruent. Do not assume that. Alright, this one is the right scale. The other one I printed off had like a tiny worksheet in the middle.
Oh, we should try to do that.
Yeah, that would be fun, right? There's a geometry joke in there about, not everything's drawn to scale. Thank you. Pardon me.
His classes in black all the class.
Nope.
Hello.
Oh, it's early.
Are you leaving?
I mean, what more do you want me to do? You're ASS.
What?
I teach some triangles here, man. You try to come up with material.
Tomorrow.
Not all of these triangles will be congruent,
Oh, wow.
or at least not assumably so.
Why is that so funny?
But
Can you zoom out a little bit so I can see the...
I was gonna do that.
basically, it's every combination of A's and S's that you can, right? Using 3 letters. Except for AAA and ASS, right?
Can you scoot down a little more?
Oh, yes, I'm sorry. So guys, you don't have to write all these down and memorize them. The only ones that don't pop up are AAA, right? Because you could have 2 equilateral triangles that are different sizes. And then also ASS doesn't work unless it's a 90 degree, right? So neither ASS or SSA work. So ass and ass backwards do not work. And AAA does not work because you could have 2 equilateral triangles that are different sizes. Yeah?
What does HL mean?
HL means hypotenuse leg. So if you have a 90 degree triangle and the hypotenuse and the leg match on both, then the 2 triangles are congruent. For now, our quiz this Friday will basically be this, identifying which theorem makes the triangles congruent. Not all of the triangles I'm throwing at you will be congruent, or at least proved to be congruent. First quiz can be very easy if you've been paying attention this whole time. If you've been sitting on your phone, it could be iffy, right? I don't know.
I've been
Trying
paying
to give you an
attention,
easy one to start
not
out.
100% sure.
But some of you guys are like, oh, this is easy, I won't pay attention. And then you screw yourselves over, right? And then when it's hard, you do pay attention, but it's hard, so you screw yourself over anyway, right? So instead of zoning out when it's easy, pay attention when it's easy and knock it out of the park. Yeah?
AAS, right before.
AAS? AAS is correct, yes. Use AAS. Every combination of A and S is fine, as long as it doesn't spell ass or ass backwards. Or AAA.
Okay, so there's angle. So angle.
Again, finding that missing
because of
side
the-
that's shared or vertical angles is pretty essential to solving these types of problems.
I know. Wait.
So this one has to be congruent in the middle.
So I can see the thing.
But there's 2 sides, so it's
Yeah, I just need
It does.
But you weren't
Yeah,
supposed
instead
to
of copying
use
those
that.
down and memorizing them, which means you're going to forget them,
I know.
how you should
So then
instead
how's
think
that
of it
work
is
out?
it's any
not
combination of
an
A
ideal
and S
name.
except for AAA and ass, or ass
wait.
backwards.
S A S.
That's it. HL
There's
is
angles
ass
in the middle,
theorem,
and then
but it only
yeah.
works for 90
okay.
degrees.
So SAS.
I need to clean out.
I'm getting this a little better. Alright.
All of these are going to be considered theorems except for ASA, which
This is
we'll
just
call
gonna be like
postulates.
number 3.
Anything we assume to be
Because
true.
there's one angle.
Theorems are provable,
And there's one
postulates
side.
are not.
And then there's the middle.
Angle siding. Because the middle end.
And the middle has to be congruent since it goes straight up. So it's angle. Side.
All right, let's take a look at number 4. How is number 4 provable?
Side.
Yeah.
We've got two sets of angles.
Doing okay.
Yes.
Angle,
Turns out if you know
side,
two
side.
sets of angles, you get the third
Do
one
that.
for free because you can
Wait,
just
so
subtract
it's
those from
angle,
180, right?
Side. No. Side. Angle.
So we know that those angles are all the same, but
I
that's not
think
enough,
it's
right?
like
Angle, angle,
S.
angle doesn't work.
Oh,
Yeah,
I always
it's the
forget we
same.
can do 2s, so we just stick to
What
2s.
else? We need something with a side.
Wait for
And this
what?
is side, side, side.
4.
Yeah.
What?
SU, that is the.
Yep, SU is the shared side.
So I think we would
So we have angle, side, angle.
I mean, that's like pretty.
Oh, there's just that.
Okay, let's do next.
ASA.
Oh,
Side, side, side.
why is this so much?
Remember, AAA doesn't work, although you could prove those angles are congruent before proving the triangle is congruent, right? Because if you subtract blue and orange from 180, you get what's left over, which will be the same
So
as
it's
both.
angle, side, angle, angle.
Wait, number 5.
Side.
It's gonna be A.
Side, side, side.
No.
Oh,
Angle.
wait.
What? Angle, side. Angle, angle, angle. No, we can't use angle, side, angle.
We have two sets of angles that are congruent.
Side.
What are we missing from number 5?
Angle.
Side, angle. Angle, side, angle.
Side.
A saw.
Shared side, right?
Yeah.
And here it is.
Okay.
So this is going to be what? Angle, side, angle? What?
No. Angle.
Side.
Angle, angle, side.
No.
Yep.
Wait, yeah, that works.
We don't have two angles surrounding the side. Again, focus on one triangle at a time,
The 2s.
so you're not jumping across, right? We have,
Angle
if we just
sides.
focus at this
So
bottom
side, angle,
triangle,
side.
Yeah.
we've got angle, angle, side. You see it?
We'll just be doing this wrong.
It can be easy if you know what you're doing.
Bad if it's
It can be
all wrong.
impossible if you don't,
Angle,
guys.
angle, side.
Yeah, let's see if it's right.
Okay.
Number 6.
So far.
I hope you see the shared side by now.
We got the first one wrong.
Which one's that? What theorem is that going to be? Just focus on the bottom triangle?
Be like
How's that?
side.
Wait. Oh.
Side, angle, side, right?
Okay, so it's like the double, it's like a second. Okay.
Right. That makes sense. We just wrote it in the wrong order.
Skip to 11.
Yeah.
Sass.
Yeah. I keep forgetting that there's the
Self-development points on the line. Prove it congruent. I'll give you one self-development point.
Well, doesn't it have to be since they share it?
Yeah.
Okay, they share a side.
But they share the middle line.
Well, that's very
Oh, we're
common.
looking at 11. Okay.
So it makes it congruent, right? Or
Yes.
what?
It's I think so, because they have to
It's
share
sass,
it.
right?
That side is congruent, but are the triangles congruent?
Yeah, it's side angle, side angle, side.
Focus on one triangle at a time. Focus on the top triangle.
Side angle, side. Right?
Not side angle side, because side angle side says the angle's in between the two sides. See the two sides? It would have to be that angle we
Side,
know.
side angle, or what?
Side angle is ass backwards. We don't know it to be a 90 degree.
So I think so.
Are they congruent or are they not? Now we know we have well, don't be confused. If we can't prove it congruent, it doesn't mean it's not, right? I could give you two triangles that I've measured out perfectly and I know they are, but I'd give you no information about them. They could be congruent, right? All we know is that if we can't prove it, it could be. So either I want you to prove that it is congruent or it's not congruent.
Turns out we both.
So I'm erasing.
Zayden.
It has to be congruent because no, it's not. Never mind.
Erase the left. Circling it so I can go back and figure it out.
You're saying this angle here has to be the same as that angle there?
Oh yeah, because
It's like
It does look like a reflection, but how do you prove it?
correspond.
Oh. Yeah.
Corresponding angle.
Right now, the information we have right here
Wait.
spells ASS, which is not a theorem, right? It doesn't
Wait,
work.
the one thing, which name I don't know, but like it flips over the line, you know?
A reflection.
No, maybe. So if there's like two angles on the same line, it starts with an L.
Linear pair.
Linear pair.
Okay? These two angles are not a linear pair because they don't sum to 180. They're not two angles on a line. That's not going to work. Either prove they're
Into
congruent or
the-
they're not congruent. You should be able to do it for number 11.
You have to like flip it.
Number 11's tough.
So like they flipped it. I don't know.
There's no way they can't be congruent though, right? I mean, they have to be.
Not necessarily.
But if you change these two,
Turn the page, look at number 13.
that's how math works, right?
Actually, look at 14. Congruent or no?
SAS.
Side angle side. Where's that missing angle that they didn't give us, Noah? Yep.
Might be
Vertical angles. So we know side angle side.
I saw.
Look at the bottom. The bottom says triangle FIG is congruent to another triangle. Turns out FIG on any of these triangles will be congruent to the same triangle. So look at 13. FIG is going to be congruent to HIG. And I write it that way specifically. FIG is congruent to HIG. I try to match up the letters as much as possible.
Yeah.
They both share angle G, right?
Where is ABC?
And I.
ABC. So
F and H must go together then,
or CB.
if they are congruent. And I know they're congruent because side says
Yeah,
so.
EDC.
So when you write two triangles are congruent, you're supposed to match up their letters as much as possible. So G and I match up, so I wrote those in the same spots as G and I. And F and H go together as well. And that'll help you because when you fill this out, it turns out that those measures to those angles will also match up. F and H go together,
Wait.
I and I goes together,
So it's Q, P, and right?
and G goes together.
Is that right? Q, P, N?
I think so.
But the information we got was side. And that's what told us it was congruent. So the bottom really is just an exercise in matching up the letters as best as possible, right? So when you write that they're congruent, make sure you write it where the letters match up. So for instance, number 7 says ACB. Let's find a triangle with ACB. How about this one? ACB is going to be congruent to what triangle? Well, this one. How do you want to name it?
PQ.
Do you want to call it ECD or DCE? ACB is congruent to what?
See, this we can do.
Sure.
Turns out these angles are congruent.
STU, right? Wait. Yeah?
And so are these. How did I know that those were congruent?
That might be right. Yeah.
And not A and E?
IG. D.
Question for another time.
HIG.
Yeah.
So big.
Has to do with number 12. Was it 12 or 11? 11. The one that we got stumped on earlier. Yeah.
C.
After this, I want to try something for
So ACB is going to be congruent to DCE. Purple, orange, green. Remember, triangles are called triangles because they have 3 angles. They are named by their angles, not their segments. That's why we have triangle ACB.
Yeah.
Angle A, angle C, angle B is congruent to angle D, angle C, angle E. So D,
So TUS.
C,
Okay,
and notice C lined up with C naturally. That's good.
Yeah.
Okay.
B and E are both green.
Okay, so you know
D
what?
and A
I
are both
think
purple.
we need to do these right.
Uh-oh.
All right, you want to talk about number 11?
So does that mean
Zane?
all of
All right,
them
so
are
Zane's got an
alive?
idea for 11.
We just switched it around.
Here's what I'm going to do. I'm going to draw 11 a little bit bigger
Wait, so.
on a different piece of paper.
I have a question.
What?
On the back for these questions, is there only one correct order?
Yes.
All right.
ACD. Oh. DCE.
Looks like we've got something like this.
Uh-oh.
Wait, where?
Where did the E come from?
This is J,
I was just reading those letters.
M, L, K, and they gave us
What did we
that
do?
this is congruent
ACB.
to this. This angle is congruent
You know what?
to this angle,
We're gonna say these are right.
and that shared side is congruent, we found out, right? All right, Zayden, how are you going to prove these two congruent?
I used corresponding angles postulate to make the angle K, the entire thing, all of it, and then I drew that line, the KL line, I drew it out, and then made.
All right, so he's extending KL. Are you guys seeing what he's doing?
Yeah, well,
Yes.
He's extending KL. Yeah?
Yes.
Could he use alternate interior?
That's another thing as well, yes.
That's the
Exactly.
word
You
I
guys
was looking
seeing the
for.
transversal? We have two parallel lines cut by a transversal. How do I know that they're parallel? How do I know those two lines are parallel? Yes, there's the same angle between them. Those lines are going off the same
that's what we
angle.
had. It was-
So Zayden, what did you do?
I made.
I mean,
I determined that the angle L will be 180 minus K because it's a linear pair with angle K.
Okay, so check it out. Do I want to let you jump that far? Hold on a second.
I'm just gonna put down zeros.
Yeah.
Just in case.
So
Does that mean
Zayden knows
everything's
that this
wrong?
angle and this angle are congruent. How do you know those two
I
angles are
feel like
congruent?
all these are wrong.
I know those
Just
two
check
angles are congruent
ABC.
because
It's congruent to.
they're both a linear pair
Where
with
did A-
angle K.
You don't know
so it
that.
should be ABC.
You can't prove that
I think
yet.
we got most.
So
It's just
let me help you out.
You have to do it in exact same order.
I think I jumped the gun a little bit.
Wait,
So notice that these are both in the same relative position.
G-I-
We have two parallel lines. This line right here is parallel to that
But
line,
with this you did
being cut by a transversal.
ACB and DCE.
Let me rephrase that. We have two parallel lines. This line here and this line here being cut by a transversal. Two
Maybe it's
parallel
just like
lines
for
cut
that
by a
problem.
transversal. Corresponding
But
angles.
if not, we have
So
everything
these two angles are
backwards.
equal.
Like, we do
Which you're saying is then a linear pair with K.
Yeah.
GCB.
No, I think if anything we have it.
With this
would be
angle.
GI.
Okay, that's fair.
And then DC.
Yeah, so we have it backwards.
So these two are a linear pair.
Well, that is backwards.
So that means that
Okay.
the blue angle will be 180 minus K.
Okay.
And then I also said that angle S is going to be 180 minus K because it has
Angle what?
angle.
J?
Yeah,
There's
angle
an- yeah. Angle J is also going to be 180 minus K.
and that says that both those angles are the same.
Mhm.
And then that means that we can say that the last angles are the same, and that gives us three angles and two sides. Also,
Angle, angle, side, angle, angle, side.
We have a test.
So this one's a little more complex. So what he did was he said, look, these two angles are the same by cap, which means these two angles are the same by cap, and that's the same by vertical. So now we have angle, angle, side, angle, angle, side. So we proved it by angle, angle, side. Well done. One supplemental point for you, and Ellie, you're going to get one as well. You saw it. Well
So
done.
we did that.
So what was the answer? Like
Angle, angle, side for number 11. So let's go back to 11.
I thought we couldn't do that though.
Angle
Not with the
side.
information we had.
Oh.
So what Zayden was saying, for those of you that weren't paying attention, okay, is he's saying that this angle here is going to be the same as this angle here by cap, because we have two parallel lines being cut by a transversal. Sorry, let me say that again. Two parallel lines being cut by a transversal. He knew that this line was parallel to this line, because they're going off at the same angle here and here. And then he said, with that information, I can say these are the same, which means these are the same. So now we have angle, angle, side.
So like, are there gonna be any of those on the test or?
Yep.
Okay.
There might be one of those tough ones on there.
Oh, what are we doing tomorrow?
More of this, and then Thursday we'll review for our quiz, and then we'll have a quiz on Friday. Quiz number 1.
Wednesday.
I'll be gone.
What?
Wednesday we really have it.
Yeah, you guys don't your half day.
Yeah, I'm gonna be gone
Wednesdays are
tomorrow.
But we also have Monday off for MLK Day. A dream of a day, right? So,
I have a dream that
Right.
little black boys and girls
I'm still gonna play guitar, but I got through. So, you know.
our schools are more segregated now than ever. Not that I need to tell you that, right? But yeah, it's awful.
two we made on
Right,
like
it's more
years,
segregated now than
and then he
ever.
told
We
us
don't
to do
actively
classes
do it with
slash
laws
so I spent,
necessarily, but
like,
we do
a
it in
week
other
and
ways,
so
and it's really
doing that
awful.
for no reason.
It is not a
That,
use.
like, you know, I'm done. I mean, I literally had this
We've
beer,
gone
it
backwards
looked
in many
great,
ways.
and then he's like, okay, smash it. I'm literally like, it's fine.
Leave that for tomorrow, we'll talk about it.
It's just a week's